Hello everyone. In this video, we will discuss the Fundamental Theorem of Calculus, Part 1 and Part 2. Fundamental Theorem of Calculus, Part 1. If f is continuous on closed interval ab, then the function uppercase f defined by uppercase f of x is equal to the integral from a to x f of t dt, where x is greater than or equal to a but less than or equal to b, is differentiable on the open interval ab, and uppercase f prime of x is equal to d dx of the integral from a to x f of t dt is equal to f of x. Fundamental Theorem of Calculus, Part 2. If f is continuous on the closed interval ab, then the integral of f of x dx is equal to uppercase f of b minus uppercase f of a, where uppercase f is any antiderivative of f. The net change theorem says the net change in a function f over an interval, closed interval, ab is given by f of a minus f of b is equal to the integral from a to b of f prime of x dx. The following problems. Use Fundamental Theorem of Calculus, Part 2, to evaluate the following definite integral. A. The integral from 0 to 2, 4 minus x squared dx. And B. The integral from 1 to 2, x cubed minus 3 to the x dx. The integral from 0 to 2 of 4 minus x squared dx is equal to 4x minus x cubed over 3 slash 0, 2. Now this 4x minus the x cubed over 3 is the antiderivative of this 4 minus x squared based on the power rules that we knew. The slash here to the right, 0 to 2, are just your limits of integration, which we had previous. So this is the way that we write it after we have taken the antiderivative. Okay, you write it to the right, with the 0 to the bottom and the 2 to the top. Okay, so it looks like just if you're thinking of an absolute value sign, but except that it doesn't have the left side. Okay, then this will be equal to, so you're going to evaluate this function at 2 and then subtract evaluating that same function at 0. So these are parentheses right here. 4 times 2 minus 2 cubed over 3. So you replace the x with 2 first. Then subtract, and it's always a subtraction sign. Remember, it was the f of a minus f of b. Right, so this part, or f of b rather, minus f of a. Okay, so it's the antiderivative of the higher minus the antiderivative of the lower number, right? Evaluated. So then minus 4 times 0, so you replace the x with 0 in every instance where you see x, right? It's subtracted 4 times 0 minus 0 cubed over 3. And of course, this is just going to be 8 minus 8 over 3 minus 0. So we can just ignore this 0, and then it becomes 8 minus 8 over 3. And then that's your answer right there. Okay, let's look at the integral between 1 to 2, of x cubed minus 3x, 3 to the x rather, x cubed minus 3 to the x dx. Okay? So then, what are the antiderivatives for these? For x cubed, it will be x to the 4th over 4. So remember, it's a power, so you go up 1. That's 3 plus 1, that's 4. And then you divide by the exponent. For 3 to the x, now that is a little different animal right there. You have to remember when you did the derivatives of ln functions, and then what you want to do then, your side work. Remember rather that the d dx of a to the x was equal to a to the x ln of a. So the derivative of 3 to the x would be equal to 3 to the x d dx. 3 to the x is equal to 3 to the x ln of 3. ln of 3 rather. And then if you want to think of this backwards, then that is how we get the 3 to the x over ln of 3. Just reading it backwards, going from integral to derivative, or from derivative to integral to antiderivative. Okay. If you read further, we would have there's another general formula that you might come across later, that the integral of a to the x dx is equal to a to the x times 1 over ln of a. So that is another integral formula that you will come across later. So if you can remember this, so you can remember taking derivatives and then thinking of it backwards to go to your antiderivative, and that is one way of thinking about it. Right? So that's how we got a 3 to the x over ln of 3, evaluated at 2 and at 1. So we're going to evaluate the 2 and subtract the evaluation at 1. Okay, so this is going to be equal to 2 to the 4th power over 4 minus 3 squared over ln of 3 minus all of 1. When you plug in 1 for x, it's going to be 1 over 4 minus 3 to the 1st power over ln of 3. And then you can just remove your parentheses right here, or distribute the negative through the parentheses, and we have 4 minus 9 over ln of 3 minus 1/4 plus 3 over ln of 3, and that will be equal to, bringing like terms together, 15 over 4 minus 6 over ln of 3, and you're done. Ideas from the fundamental theorem of calculus can be applied to things like velocity and displacement and the total distance traveled. So suppose, here's a question, suppose the graph represents the velocity of a person in miles per hour at a time t hours. So here's your graph. It's like a triangle there, another triangle right here. Looks like. So we've shaded the parts, and there's one between 0 and 2, that part is below the x-axis, and between 2 and 4, the part is above the x-axis. I want to calculate the displacement. Displacement is the same as your net change. Remember we talked about a net change theorem there, and net change is displacement. No application, is displacement. So I wanted to find the displacement over the interval 0, 4. Now displacement can be positive or it can be negative. It can be positive or it can be negative, because it's a net area. Okay, so let's take the integral between 0 to 4 of your velocity function. Let's call it v of t dt. And so you're looking at the area of the two triangles. Net area, one's that's below the x-axis is going to take on a negative sign. One that is above the x-axis is going to take a positive sign. So for the one that's below the x-axis, it's going to be half base times height, but it's going to be negative. So it'll be 1, negative 1 over 2 times 2 times 2. Then for the one that's above the x-axis, the triangle above the x-axis is going to be positive, so that's negative. That's positive 1/2 times 2 times 1, so that's going to be negative 2 plus 1. So that's going to be equal to negative 1. Right? So that's negative 1 miles. That's your displacement. Now you want to find the total distance. Total distance is positive. So it's like taking the absolute change. The absolute change. So that's one way of looking at it, is absolute change. So that means that whatever was negative, so the negative section, you change that to a positive. So where it was negative 1/2 here, do a positive 1/2 plus 1/2 2 times 1. Okay, so that's going to be 2 plus 1, which is equal to 1. Another way of looking at it is that you could think of the positive part and then subtract the negative. So you could either think of it in absolute terms, or you could think of positive minus negative sign. So you could start with a positive sign and then subtract the negative, and you still get a larger, because negative, negative, or minus negative gives a positive. So you can think of it in two ways, right? And you still be correct. Okay, let's look at another example. A particle moves along a straight line with a velocity v of t is equal to t squared minus 2t. Determine the displacement of the particle from t equals 0 to t equals 4, and then determine the total distance traveled by the particle from t equals 0 to t equals 4. And we know that displacement is a net change, which is a net change in position. So again, it could be positive or it could be negative, all right? So if we want to sketch the graph real quick of what that could look like between 0 to 2 and 2 to 4, this is what the graph of that function looks like. So here we are at 0. Let's change our axis to a different color. 0 to 2 and 2 to 4. So we're thinking of this graph. We're thinking about areas. Eventually, when we integrate, we're going to get areas, so we can kind of like shade these in and see what happens. But net, we treat the area above as positive, the area below as negative. And so the sign, you know, it depends on which has the larger net area. So, okay, anyway, so let's do it. Using our power rule right here, integral 0 to 4 t squared minus 2t becomes t cubed over 3 minus t squared between 0 and 4. Okay, so then we plug in our 4 first and then plug in 0 afterwards. So that's going to be 4 cubed over 3 minus 4 squared minus 0 cubed over 3 minus 0 squared. Obviously, the second part here becomes 0. And we have to always remember to plug in our zeros in our functions, because many times when originally we get these and the second part always goes off to 0, then you might fall into the trap of thinking that, okay, for every single function in the world, it's always going to be 0. But it's not always the case that this, when you plug in 0 into any function, you always get output of 0. Okay, so be careful of that. All right, but in this case, this 0, so let's treat it as it is. There is correct. So that is equal to 64 over 3 minus 16 minus 0. And so you can leave it as just 64 over 3 minus 16, or you can simplify this part a little bit more to get 16 over 3. Here's the total distance. The total distance is absolute. It's always positive. So you could just put absolute values over the negative part, or you could do the positive part minus the negative part, and then that still gives you a positive. Okay, so let's do it this time by taking the positive part, subtracting the area that would be negative. So the integral 0 to 4 of t squared minus 2t dt is going to be equal to the integral, the positive part, which is integral of 2 from 2 to 4 of t squared minus 2t dt, and then minus the integral of the area that's going to be negative, which is 0 to 2, the integral from 0 to 2, t squared minus 2t dt. And you use your rules of integration that you learned in your power rule right here. This becomes t cubed over 3 minus t squared between 4 and 2 minus t cubed over 3 minus t squared between 0 and 2. Plug in your 4 and your 2 in the first part, and then plug in your 0 and 2 in the second section. So that's 64 over 3 minus 16 minus 8 over 3 minus 4, then minus again 8 over 3 minus 4, then minus the 0 cubed over 3 minus 0 squared. So that's going to just all be 0. So that all becomes 0. So we can now distribute all our negative sign through. 64 over 3 minus 16 minus 8 over 3. It's 8 over 3 plus 4 minus 8 over 3 again plus another 4, and after you've done all that, you get that be equal to 48 over 3 minus 8. We can say that that is our final answer. So that is our total distance traveled. Thank you very much. Like and subscribe. See you next lesson.